So modify your program to create 16-bit running light. 16-bit, okay. Using the LEDs from port A and B. Ah, oh, that's cool. That's cool. Okay, so we're now going to use both these and these. All right, all right, all right. We're getting fancy. So, how do I do that? Use only loops, no decisions. Okay. Download the program to the microcontroller and test it. This lesson's getting a bit long now, so I might stop. But okay, so let's first bring in both LEDs. We want port A and port B. So this one here can be port A. So we've got port A, port B. So now I'm writing the counter value to both A and B every time now. So just to make sure, let's just let's just simulate that and just make sure that works. So they should both be going in tandem now, which they are. Bit of a skip there, which is grinding my gears, but okay. So then now what we want is we want it to fall off one and go to the other. So how do we do? Okay, I just sat back there and thought about it. So what jumps to my mind is what we're going to say is, we could just do it in 2 loops actually. So we just say whilst the counter is less than 129, yeah, then write to A. And then whilst it's greater than 127, then write to B. That should be pretty simple. So if I just do 2 while loops, whilst counters, no, okay, wait, hang on. Let's do another while loop here. So we're saying whilst the counter is less than 129, then write to port A, yeah, and shift it left. I'm glad I'm not doing multiplication again. So let's just make sure that works. So whilst the counters, yeah, there we go. So 129, shift left. Yep, cool. That worked. I don't know why it didn't do anything else afterwards. So whilst counters, let's do 129, then do that. And then whilst it's greater than 127, so that obviously is 128. So whilst it's greater than 127, does that, and then write to port B and keep shifting it. Is that right to port B? No. What happens? Because yes. My variable, it's losing it because my variable is just an 8-bit, isn't it? So that counter there is just a byte. So make it an unsigned int. Okay. And go again. So again, this is an introduction to microcontrollers. So does the person know what an unsigned int is? So okay, that hasn't worked. And it's broken. What's happened? So my counter. I'm used to PLC data types, so I don't I'm not fully with it with other data types, but so I think my variable types is still not right, but let's just assume it is. I've given an int. It should be really an unsigned int, or let's say a word or an unsigned. No, I mean it should just be unsigned int is correct, I think. So whilst it's less than 129, count up, and then break out of that loop when it's not. So once it gets equal to 128, then write that 128 value whilst the counter is greater than 127. Yep. Write that there. So that should work. So let's simulate that, but let's go slower. So it is counting now. So what's happening there? It's counting, but it's not. I've seen it. So if you look here on the right, it tells you my value of my counter, and it went to like 32,000. So that's like the max integer value. But why did it go so high? So it's at 2 right now. Look at my counter value, 8, 16 as we expect. So then what happens there at this point? It goes to 512, 1024. So why is it not displaying on here? Yeah, okay. I feel a bit better now, so it's not displaying on here because this value is 1 again, isn't it? so it wouldn't display there. So I could use gotos obviously to jump around the code and do that, but I don't, in my head I can't think of a way to make this value equal something else. It just seems a bit ridiculous. So I could use two variables and have two counters. So I could use two variables and write one counter value to the top set of LEDs and one counter value to the bottom set of LEDs. And that's probably the way that I'm going to do it just to get through this lesson. I'm kind of, I'm done with it now. Modify your program to create a 16-bit running light using LEDs. Use only loops, no decisions. So yeah, it doesn't say I can't use two variables. So I'm going to use two variables. So we're just going to go with, set that back to 8-bit. Edit while in simulation. Set that back to a byte. And then, so we'll call, let's call that counter A. And then we'll make another counter. Call that counter B. Also a byte, 0. Alright, so then we're going to say, whilst counter A is less than 129, write to that port A. And then when counter A is greater than 128, or 127, then I'm just going to use greater than and equals, because even I'm confusing myself on the 129. So let's use greater than or equal to 128 and less than or equal to 128, or less than or equal to 128 and greater than or equal to. How does that not work? Greater than or equal. Yeah, okay, that makes me better. So if it's less than 128, do that. If it's greater than 128, do that. But when it's greater than 128, then write the value I kind of want to do now, and counter B is I'm confusing myself here now. Whilst and counter B is greater than or equal to, and then so write counter B's value to port B, and then start shifting it. This is why I need simulation to run now, because I can't work this through in my head like this. So we shift in A through, run out full speed, and then what do we do? What happens now? That just keeps going because A is less than 128. Why is A less than 128? Whilst counter A is greater, because I guess this bit's never true. So if counter A is greater than 128, then what happens? Run that. Then start writing to counter B. Then this should start doing something. Nope. So we set counter A to 1. Can we do the same here? Counter B to 1. And then whilst counter A is greater than, do that. And then whilst counter B is less than, I keep saying the less than and greater than the wrong way around. Apologies. So whilst counter A is less than 128, do that. Whilst counter B is less than 128, do that. And then if none of them are the case, then we're going to reset them. I think this should work. This should do something now on B. Just not right into. So again, still. So I know I need to reset here. So at the end of the program, set them both back to 0. But I'm not sure why it's not doing anything on B. So this should at least just keep looping this thing round. I don't know if it wanted me to count backwards. Okay. So why didn't that loop start again then? Because now at this point, counter A, you what? So at this point, counter A should then go back to being 0. So it loops through, and when counter A is, oh, does it just get? I'm having the same problem again, I think, whereby now A becomes a nonsense value. How do I solve that without whilst it's less than 128? I think this solves it, but it's not going to turn on bit 7 again. Okay. There's some progress there. Alright, so I've done it now. As you can see here, it's ticking over and it's going to fling around. I haven't done it in a great way, so you know what I did was I went, took a break, ate, and then just spent like an hour playing games, and now I'm back. So I thought, let me just write this code off video because it's going to take me ages, and I haven't done it in a clean way. And I guess what I could start doing is start embedding like some of these loops into functions and stuff like that, or embed this sort of stuff into functions. But for now, it's okay. So start the program. I had this like declaration where I was setting both counters to 1. I had that outside the program, so it's like an initialization thing. But now at the beginning of each cycle of the program, I set my counters back to the initial value of 1. And then at the end, I set counter B to 0. And once I'm done with the first row of counter A, I set that to 0 as well. So let's go. We set everything to 1. Then, whilst counter A is less than 128, meaning that it's less than this top bit here, whilst counter A is less than 128, which is this bit here, then I'm writing obviously to the counter as normal. I'm writing to the LEDs as normal. Then when it reaches 128, I still want 128 to turn on. So this is like the edge case that I need to deal with. So it's not really an edge case, but this is the case that is not dealt with in my loop. So once it jumps out of that loop and it turns on that bit there, I then write that same value because it jumped out of the loop now. I write that now to the LED, so that turns on that last bit, that bit 7. Delay that for 500 milliseconds, so keep that on. Then set the counter to 0, and then write that 0 to the output, so to the LEDs. So that will then. This writes the last bit 7, turns bit 7 on, leaves it on 500 milliseconds, then sets counter to 0 and writes 0 to the top output, meaning turn all the top LEDs off. Then I just rinse and repeat again the same exact code again now for B. And again, this should just be turned to a function. I should just be passing in parameters, but I don't know how to do functions and parameters yet on this flow code. So again, I'm learning microcontrollers, but probably more than anything, I'm kind of learning flow code as well. So is that a good or bad thing? I don't know. What I want, I guess, is to be learning microcontrollers. I want to learn how this works, not how the flow code works. But yeah, I'm learning both at the moment, which is fine. So I will, because I just think this video has just gone on way too long. I'm gonna leave this next bit here where we create a flowchart that contains an array of 4 variables. I'm gonna leave that for the next video, and hopefully that video is just like 2 minutes. And it's just easy to do. So anyways, all right, thanks for watching this one. Hope you enjoyed it. Take care. Bye-bye.